Hello everyone, I'm Alfian and today we are going to solve the Hackerrank problem solving section on the drawing book talents. And for this challenge, it says a teacher asks the class to open their book to a page number. A student can either start turning pages from the front of the book or from the back of the book. They always turn pages one at a time, and for the starting point, it's always showing the page number 1 on the right side, and when they flip page 1 they see pages number 2 and 3, and each page except the last page will always be printed on both sides. The last page might only be printed on the front. Given the length of the book, if the book is n pages long and a student wants to turn to page P, which is the target page, what is the minimum number of pages to turn? And for this case, either student can either turning from the start of the book or from the end of the book, and the M is the total number of pages of a book and the P is the target of the pages of the book. And then we need to count how many pages in order to get to the target page of the book, which is the P value right here, or the P variable right here. So without further ado, let's implement this. Since I'm using the TypeScript, then the output function will always return a number, and it is the expected output. Let's make a premature return if the target page is 1, and then since we are always starting from the page 1, then we don't have to turn or flip the book at all, since we already meet the requirement. And also the same thing also applies to the end of the page. Let's say if the n is 6 and then the P is also 6, which is the target page, if it's already 6, then we don't have to turn anything from the back of the book because we already found the desired page of the P. Let's implement this by using the if the P is strictly equals to 1 or the P is strictly equals to the n page. If it is, then we are returning 0. And let's declare a constant variable for counting from the start of the book by using the from start, and then declaring the target book, comparing the target page with the starting of the book. Let's say if we need to find how many pages to turn in order to get to page number 3, and we can compare it with the page 1 from the start of the book by using the P divided by 2, and then we can get how many pages that we need to turn. So if the P is 3, then divided by 2, and we got 1.5, and then we can round it down to 1 page. And also the same thing to page number 2. 2 divided by 2 is equals to 1, and then we don't have to round it down because it's already an integer value. And also the same thing for the P value of 4. If it's 4, then we divided by 2 and we got the desired term. 4 divided by 2 is equals to 2, and it gets 2 pages to turn. And also the same thing also applies to 5, which is 5 divided by 2 is equals to 2.5, and then 2.5 rounded down to 2, and then the pages to turn is also 2, 5, and then 1, 2, and then we got the from start value or from start variable, correct? And let's count it down to from the end, and we need to compare the end value by comparing the total number of pages with the desired page that we want by using the Math.floor, not Math.floor, but let's implement this incrementally, or like step by step. the total of pages divided by p, which is the difference from both of them, the total page and the desired page that we want, and then divided by 2. So let's say if we want to get to the page number 3, and if the pages is 5 or 6, then from the end, then we have to turn 2 pages to get to the page number 3. And in order to do that, we need to subtract the end, the total pages, with the p. Let's say 6, the not divisible but subtract by 3 is equals to 3, and then divided by 2, we got the 1.5, and then we can use the Math.ceil to round up the 1.5 to the number of 2. Let's say if we have the 6 pages, n equals 6, and then the p is equals to 3, then from the n, we can use the Math.ceil or by 6 subtracted by 3, and then we get 3 divided by 2, and then we got 1.5. Since it's 2 pages from the page 6, then we need to round it up to 2 using the Math.ceil. Let's use this. Let's implement it. Math.ceil. And also don't forget to use the Math.floor. We already implemented from the start of the page, and then compare those two from the start and from the end using, we need to somehow get the least terms either from the start or from the back of the book by using the math minimum, by returning the math minimum, and then compare which one has the least value or the least terms in order to get to the p number of pages, and using the from n, and let's run this code to see if it works. And we got the wrong answer. The example is the total pages is 5 and the desired output is 4, or desired page that we want to turn. Let's say if we, maybe it's because the front end is incorrect. Let's implement this. If the n or the total pages is 5 and then the p is 4, from the n we can count it by 5. Let's test it out. 5 subtracted by 4, and then we got 1, and for the 1 value divided by 2 using the current implementation, divided by 2, which is equals to 0.5, and then if we use the Math.ceil, we got the 1, which is the wrong answer because 5 and 4 is always on the same page. If we turn one page, then the desired page is 4. It should be 0 because we don't have to turn anything. If we turn 1 pages, then we got 2 and 3, which is far from the p or the target page. So let's implement this by using the Math.floor instead of Math.ceil. Let's run this again to see if it works. Okay, so it's returning correctly. Let's run all of the test cases by submitting the code, and now we got one error, which is the test case 26, and this is the sample test case of 6 and 5. The n is 6 and then the p is 5. Let's test this out. N is 6 and p is 5. So let's using the test against custom input. total number of pairs is 6 and the pairs to turn into is 5. Let's run this code. Since 6 is one page away from the page number 5 and 6 is on the other page, yeah, and we got the wrong value, which is 0, because 6 is one, because between 6 and 5 it has one page difference instead of 0, because 6 and 5 is not on the same page. Let's solve this by using another implementation. Let's use the Math.floor. Using the n, let's try n divided by 2 and then subtracted by p divided by 2. Let's run this code. Using the test against custom input check mark, it's still returning 0. Yeah, maybe the implementation returns the same thing. Let's say if the n is 6, using the Math.floor, n 6 and 6 divided by 2 minus the p or 5 divided by 2. They both returning 3 and then 2.5. 2.5 is equals to 0, not 0, but yeah, 0.5. 0.5 using the Math.floor is equals to 0. So let's using the, instead of Math.floor, then we need to get back to the Math.ceil using the previous implementation. So instead of getting the 0, 0.5 will equals to 1 because we are using the Math.ceil or round up. Okay, so it's returning as expected. Let's submit this to see if it works. Okay, so we got many errors, many test case errors of the 5 and 5, and then the p is 4. Let's see why is it returning error. Maybe using the previous implementation error is already correct, but it only has one error. Let's run this code. Yeah, we don't have to turn anything because the total pages is 5 and then the desired page is 4, and since 5 and 4 is on the same pages, then we don't have to on the same page, then we don't have to turn anything or return at all. So the desired value should be 0 instead of 1. So let's use the Math.floor by flooring everything before doing the subtraction. Let's run the code to see if it works. Okay, 5 and 4 is on the same page, so we are returning 0 and it's already correct. Let's implement it. Let's adding a test case of total page of 6 and then the desired page is 5. Let's run this code. It should be returning 1. Yeah, it's success. Let's run this by submitting the code. Okay, everything was a success. Okay, so that's about it. I hope you understand my explanation, and if you have any better solutions, you can write in the comment section, and also if you still confused, you can also write in the comment section. I will happily answer it. I hope you have a great day, and I will see you in the next video. Goodbye.